Yeah. All right. Yeah. So like I said, I made quite a few changes. Basically, so I think I mentioned a couple of times yesterday that that when we're doing this style of development, there's a fair amount of configuration involved, a fair amount of just sort of upfront, I've got to set up this XML file and this XML file and this XML file. And particularly so when you're dealing with Spring. Spring has over time become a lot less XML driven, but it still needs some. So I figured that at some point during the course of the day today we would start working on Spring, and I didn't want to have to make you guys wait while I copy and pasted all these different files around. So I just did it last night instead. I got ourselves set up for basically I Springified the whole training project here, the whole contact list project. It should be if we go, we'll go through and look at the structure, and you should find that it's basically the same. There are some minor differences in the Java code, which we'll talk about, because that's obviously that's part of the point of the class here. And a lot of the changes are just additional XML configuration. Okay. So first things first. Let's look at the POM, right? Look at our Maven POM, and we can see some fairly significant structural differences here, right? Before, in our dependency list, really the only compile dependency that we had was the Java EE API, right? We said that the Java EE API was the API that we're programming against, and then everything else is just implementation details that is managed by the container, right? So in this case, Jetty. Now, Spring is essentially a competing technology to the whole J2EE suite or whatever. So instead of having our stuff be managed by the J2EE container now, we're going to have Spring managing our whole application context, right? So it's no longer set up that Jetty, like you can see our Jetty Maven plugin used to have all these dependencies in there, right? No longer does. Yeah. Come in. Yeah. So Jetty's really just a thin server now. It's responsible for next to nothing at this point. And then you can see I basically moved all our dependencies up into the main dependencies section here. Now, I'd still like to be basically independent of my HSQL and my connection pool and all that stuff, and I'm just going to rely on our own sort of self-discipline to not use those specific APIs, right? If we wanted to call into them at this point, they're actually available to us, but we'll just sort of ignore them, right? Likewise with Hibernate, right? Hibernate, we actually have direct access to the Hibernate specific APIs now, right? It's not merely a JPA provider, but we'll still use it as such. And the obvious additional dependency that I've added here into the Maven POM is Spring. So I've added two dependencies. One is on the Spring Web MVC module. I guess I should mention, we were talking sort of after class ended yesterday about Spring's overall project structure a little bit, and reasons why you would use Spring instead of EJB, for example. And part of the reason is because Spring is fairly modular, right? So we're going to be using Spring's MVC subproject, and we're going to be using something called Spring's Data JPA subproject as well. So this is a set of helpers for working with Hibernate in Spring. Right? Spring has a whole lot of other projects that we could have sort of cherry-picked from as well, but just to keep ourselves fairly slim and lightweight, relatively speaking, I'm just pulling these two in. Okay. Now that being said, if I go, you know, so we're in Eclipse here, and Eclipse can kind of show us what our actual Maven dependencies are. So if I go and look at our Maven dependencies, you'll see that there's actually a lot more here than just the ones that we specify. This, by the way, is another really compelling reason to be using Maven instead of copying these jars around by hand. It's because, you know, not only do we need the Java EE API and HSQL and BoneCP and all that, we're getting all this additional stuff. JBoss logging, JBoss transactions, Spring ASM, Spring Beans, Spring Context, Spring AOP, and all this kind of stuff, right? These are all dependencies that are sort of pulled in transitively because our dependencies depend on them, right? Spring JDBC, Spring ORM, Spring TX, and that's our transactions package, right? So all this stuff is pulled in for us, again, by virtue of the fact that we're using Maven. So actually, quick question. Are any of you guys actually using Maven to manage your projects? Yeah? Oh, that's excellent. All right. Very good.
We are using Jetty server, and why we are having the JBoss related jar files here?
Yeah, I don't know who depends on this JBoss stuff. I don't know. I don't know who's depending on this. Maybe here.
Jetty is JBoss, right?
Jetty is actually an Eclipse project now.
It used to be JBoss, right?
JBoss uses Jetty.
Well, we can see here another nice thing that Eclipse gives us is this dependency hierarchy. So let's. I don't want test scope though. Hang on. I want. No, I guess that's okay. Yeah. So JBoss logging is used by Hibernate annotations. JBoss is So Hibernate is using JBoss. Dude, why can I not scroll this list down? All right. Well, anyway, good enough.
What is the difference between the scope, runtime, and compile?
Oh, very good question. Oh, and actually, I sort of, come to think of it, I actually sort
How
of.
do you get that dependency thing?
I opened up the POM, and you can see
I see.
in the tabs here the dependency hierarchy. Yeah. So the question was, what's the difference between this runtime scope, this provided scope? There's other things that might be in compile scope and so on. So I actually sort of lied. Yeah, I actually sort of lied here because. Did I lie? Yeah. Yeah. This runtime scope basically says, okay, these jars are going to be on the class path only when we do a Jetty run. They're not going to be on the class path when we do a compile. So actually, holy crap. So actually, like I say, I lied a little bit because we actually couldn't use the Hibernate specific APIs. If we wanted to, we would say that they're either compile scope or provided scope, meaning that that we can compile against them, but we won't have it in runtime because something else will be providing it. So provided scope is the opposite of runtime scope.
So if you try to use any of the classes that compile them, it would
The compiler would complain because they're not on the class path.
So
Yeah,
who's
sorry.
providing them?
For the runtime scope stuff or the provided?
Provided.
The provided scope. So this Java EE API, right? Who's providing the Java EE API? It's not this jar, right? This jar is just a bunch of interfaces, right? Who's providing the implementations for the Java EE API? Jetty. Yes. There we go. Oh my god, this looks terrible. All right.
So we can't use them in our project if it's provided, right? For compile time.
So we are compiling against the Java EE APIs, right? That's important. Anything that's in provided scope, we can compile against, but this jar won't be on the class path when we run. It'll be some other jar that's providing those APIs. This Maven terminology is a little bit confusing, like runtime scope. Runtime scope makes sense.
How does it ensure that at runtime something else will be available? I mean, as a developer, how would you ensure?
So this is for runtime scope. This is only if we're doing like Maven Jetty run, for example. But for like if you're deploying into some other container or something, we have no way of guaranteeing. Yeah. So this is really only a Maven thing. This is only for sort of our testing purposes. There's another scope called test, right? The test scope. So you would have JUnit in test scope, for example, right? JUnit, we don't want that on our compile time class path. We want that on, we do need to compile against JUnit, but only when we're compiling our tests, not when we're compiling our production code. Right. Yeah. All right. So that's all Maven stuff, right? All right. What else? What else have we got here? Let's look at persistence.xml. Persistence.xml used to have a lot of information in it about the database, right? But we don't have that anymore. Now that's sort of a thin shell. Instead, all that information is moved into the Spring application context. By the way, if you guys want to pull this down, this is all checked into Git now. So you can pull that down. Basically, a lot of the stuff that we had set up in our Jetty env and in our web.xml and our persistence.xml, this is now moved into the Spring application context. It's now
So
Spring.
you manually created this?
Yes. Yeah. So it's Spring that's managing these things now. So Spring is now aware of a bean. What's a bean? Before we even talk about what this bean is, what's a bean in general? What's a Java bean? Or a Spring bean?
Object properties.
It's an object. Yeah, it's a stupid name for a plain Java object, essentially.
Doesn't it typically have properties and some types of events?
It'll have getters and setters, so it needs to follow a particular convention, but it's the convention that we typically use anyway, right? Our getters and setters.
How about event management, subscription, and all that?
We don't know anything about that.
Not required.
No.
So if I just write a class and implement getters and setters, it becomes a bean.
It's a bean because it follows the bean naming conventions. Yeah. For Spring to manage a bean is sort of a different story. So when we say a Spring is managing a bean, basically Spring, when we start up our application server and start up Spring knows how to instantiate a bonecp data source here, for example, right? Knows how to instantiate one, and then when we set properties like this, if we say property name equals data source bean, what do we think this is doing?
Setting that value.
It's calling a setter. Yeah. So this is kind of like Java in XML a little bit. This is essentially like saying, data source equals new bonecp data source dot set data source bean, right? And this one in here, we would have to say with new JDBC data source, right? So Spring is kind of doing this for us, and all right, well, why do we want Spring to basically write our Java for us? Why is that useful?
It manages the life cycle of the.
Yeah, it's going to manage the life cycle of this thing, and in particular, anything that depends on a data source, Spring knows how to provide it then, right? So that'll get us into discussion about dependency injection in a little bit later, right? Here's another one, Entity Manager Factory, right? Before, when we wanted to create an Entity Manager Factory or create an Entity Manager, we had to say persistence dot create Entity Manager Factory for a particular persistence context, and then dot create Entity Manager or new Entity Manager or whatever, right? Here, Spring knows how to construct entity managers because it has something called a local container entity manager factory bean, and this is where our naming scheme starts to get really fun. Spring in particular likes to use these very, very long class
So
names.
this ID can be anything? Bean ID?
ID is just a name. If we want, yeah, it's just a name. It can be anything.
A variable name, right?
Yes, exactly. It's just a variable name.
It can be referenced later.
Yeah, if we want to reference it later.
And the
We're-
property name is the name of the
field, or the
field.
name of the getter setter pair.
That getter setter.
Yes, exactly. Yeah, so this entity manager factory bean thing has a set JPA vendor adapter, and we're going to when we construct this thing, we're going to pass it a Hibernate JPA vendor adapter, and pass it the same sort of properties that we had passed in persistence.xml, right? So this is Spring's. I mean, this looks very similar, honestly, to what we'd had before. Very similar. It's a little bit more consistent, and this is part of why I actually like using Spring. I mean, I'm not necessarily the hugest Spring fan, but one thing that I really do appreciate about Spring is that its approach to managing the life cycle of all of these different things that you might have floating around in your container, your database, your JPA provider connection, the connection pool, your controllers, for our model view controller stuff, any services that are managed by the container, are all treated in a totally uniform way by Spring. Whereas with EJB and JPA and all this stuff, like, we had to have a number of different configuration files that were all slightly idiomatic, or idiosyncratic rather.
So you basically write a bunch of objects and then you assemble it in this XML, right?
Yeah. So this and traditionally when we're doing Spring, this was before we had annotation-based stuff in Spring. Basically, anything that was managed by your container, you would have a bean entry in your application context XML. Anything. These data sources, your container, your controllers, anything. Right?
How does Spring know that it has to read this file?
This is a special file.
The name is?
Yeah, the name. Yeah, this application context.xml. This is a special name.
So is it auto-generated or
We manually created it. How did we do that? We copy and pasted it from somewhere else. Yeah. So that's why I've done this for you, right? I wanted to get this set up in the most clean way that I know how to get it set up. Because I mean, probably one of the biggest takeaways for you guys from this course is actually not necessarily the knowledge that I'm trying to help you learn, but actually just this framework. Like, I'm giving you something that you can copy and paste from. So here's an application context.
So what's the difference between like spring.xml, spring.servlet.xml? I mean, these are all standard files.
Yeah, Spring Servlet is specifically when we're doing Spring MVC stuff. So I'll talk about that next. Sorry, I took a inopportune bite of breakfast. I guess I'll wait until I actually give you some work to do before I start eating. All right. So there's a few other things that I want to talk about in here, but actually, you know what? I'll come back to some of these things. Yeah. So this will be high level overview. I'll come back to some of the details a little bit later. For now, I'm just kind of showing you sort of the overall structural differences between what we had when we left yesterday evening and what I've done overnight. All right. Another big change that I made is I threw away our servlets. Our servlets are now replaced by something called a controller. And this is actually like a Spring controller. The code inside the controller is fundamentally the same right now. So it still has, if we look at this, right, We still have methods that, take a servlet request and a servlet response. Servlet request, servlet response.
It
And-
doesn't extend the HTTP. So
But we're not extending HTTP servlet anymore. We're simply marked as a controller. So this Spring servlet.xml says, hey, here's where we can find all these controllers.
any reason not to inherit? Any reason why the inheritance was removed?
Yeah, I'll get back to that. I mean, basically because the servlet API is terrible. That's the short answer, right? And there's also another bean that we declare in here, this internal resource view resolver, which gives us a sort of a shorthand way of referring to our views. So I'm not actually using this bean yet, but we'll need it a little bit later on today. What else? Web.xml. So web.xml again is our single sort of point of truth in the J2EE world, right? Jetty still needs a web.xml.
Question.
Yes.
So that annotation you have used on controller, contact controller, so that does it mean that it does inherit one of the Spring?
It's not inheriting anything.
No.
It's not inheriting anything. So I'll come back to the Java. Still, I'm just going through configuration still. So sorry, there was a lot of changes. In order to use Spring's MVC stuff, we need to, in order to use Spring's MVC stuff in a servlet container, we need sort of a shim between those two worlds, right? We've got our happy little Spring MVC world, and we've got our unhappy old servlet world over here, right? So it turns out that Spring actually provides a servlet. It's sort of the big, like, the big daddy servlet or whatever that ends up dispatching to all of the internal Spring stuff. So so this is called the dispatcher servlet.
Do you need to name that, or it's like you
We don't need to implement. This is just something Spring provides. So we just have to say that we are going to be using the dispatcher servlet in our servlet container. It should be loaded on startup, and it should map to, see this /star here? Basically, /star says, hey, dispatcher servlet should handle everything.
Is that like the virtual root or just the pattern?
It's the. Actually, I'm not sure I understand the question.
It's not a pattern, right? It's basically saying everything from /, right?
Well, it is a pattern, right? Yeah, I mean, it's saying that the dispatcher servlet should be any requests that come to /anything should be routed to the dispatcher servlet by default.
Well, the virtual root would be where a specific portion of the URL would map to a different service, right? So I guess Spring wouldn't care about that.
I guess not. I'm not sure what you mean. Yeah, sorry, I don't know.
So in modern terms, what happens is you have the, what is it called, the header host?
Mm-hmm.
So you specify in the headers, you specify what application this request belongs to or should be handled by, right?
What application?
Yeah. So,
You're talking about in the HTTP request?
right. So an HTTP request could actually land on a server and it can get routed to one application or another, right?
Based on
the headers or based on the virtual root.
I've never used anything like that, so I don't know. Yeah.
Why do we need this servlet again? A dispatcher servlet?
The dispatcher servlet is the thing that sort of sits in between. Here, let me. Well, I don't have to draw a diagram. I can just use my hands. So the servlet container is running a bunch of servlets, right? So when we were implementing our own servlets, it was dispatching to those servlets. How did we set up routing in our servlets?
Request dispatcher. We're doing it ourselves, right?
The request dispatcher was related, but how did we say, for example, which servlet handles which requests?
Configuration file.
in the annotation we had specified.
Yeah, there was an annotation at the top of each servlet. There was a web servlet
Web servlet, yeah.
that had a path.
Right. Yeah.
Well, that was new in servlets 3.0.
Okay.
Prior to that, prior to having that annotation, we actually needed to do this stuff in the web XML. So we would specify the name of the servlet class, and then the servlet mapping. So we would say something like, you know, servlet name address, URL pattern / address, right? Okay, so now we've thrown out all our servlets. We're letting Spring manage everything, but since we're still in a servlet container, Spring has to provide a servlet. Now we can't annotate that servlet, right? That servlet is already written by Spring. It's already part of the jar. So we have to do things the old way and reference it in here. We have to say that the Spring's dispatcher servlet is gonna, you know, we'll give it the name Spring, and we'll map it to handle everything.
So that it can use annotations to route it accordingly.
Oh, so we'll have to still annotate Spring annotations. In
So
our
so
code.
so we still when we do our controllers, our Spring controllers, we have to provide some annotations because Spring is going to be doing its own internal routing as well. Yeah. But as far as the top level, this, you know, sort of big like parent dispatcher, it basically we're just saying, okay, handle everything, just take it all. The only thing that it doesn't handle is requests to /view. /view is we used to call it /JSP, right? It was where all our JSP files were. So if you look under source main web app here, source main web app view, and I've renamed these just, you know, contact /add, contact edit, list view, right? These JSPs are exactly the same as they were before. I've just renamed the files.
So if you define any specific explicit servlet mapping,
Mhm.
then that won't get dispatched to the dispatch servlet, but everything else will get.
Yeah. So it has sort of precedence rules, right? So anything that has more components in the path. Yeah.
Is that view standard, or can we just name it as JSP itself?
You can name it JSPs. You can name it whatever you like. Yeah. But I'm going to be using the model view controller terminology exclusively now. So I won't really be talking about JSPs and servlets. I'll be talking about views and controllers, right? And models as well. We actually have an object that we can use, or a class that's called model in Spring MVC. Okay.
Actually, the requests, when you make the HTTP request, right, you'll always be making it to a view.
No. When we make an HTTP request, it comes into the servlet container. The servlet container has to figure out what to do with it, right?
But then the user is going to see the view, right?
The user will see the view.
But you're routing everything from the view to directly handle it, right? Where is Spring?
So remember, here, let me bring up a diagram real quick. This is a very handy diagram. There we go. This might help. Right? This is essentially what we've been doing before. Only slightly different. Yeah. So this thing that says front controller right now, that's the dispatcher servlet. But picture that this was just our servlets before, right? So if we sent an HTTP request to /address or /contacts, the servlet container would take that incoming request and route it to contact list servlet.doGet, right? So that would be our controller. We would then populate a model and get a request dispatcher and send it off to the view, right? And that's how it would return the response. So
What's the difference between this and that?
so here we just have one additional level of abstraction, which is that the front controller is now just our dispatcher servlet, and we're implementing several controllers now, right?
But the model appears on both. I mean.
Yeah. So here's what happens, right? The request comes in. The front controller figures out where the request should go, so it dispatches to some particular controller. The controller we will get into some method in the controller. And the controller will return, so the controller does two things, and I'll be a little bit hand-wavy about this for now. I'll just say that it returns both, but it's doing it slightly differently. The controller, again, populates a model and chooses which view to use. So this is what it's doing, right? The request comes in, the controller populates the model, and then also says which view to use, and that's sort of not really represented very well here, but it kind of comes down here to the view template.
It populates the model with actual data, or
With actual data, right? Right. The model is our actual data that the view needs, right? Goes to the view template, and then again comes back as a response. And like I said, this is exactly the same thing that we were doing with our servlets. We designed our servlets exactly the same way. Request comes in, the servlet figures out what data to use, populates the model, and then sends it off to the view.
I thought earlier I understood why we have the dispatch servlet, but now when I look at this picture, I think I don't understand.
The good news is you don't even really need to think about the dispatcher servlet. Like the dispatcher servlet, we only mention in the web.xml because we need a servlet somewhere, but we don't ever have to work with it directly. The only thing that we ever have to do is go ahead.
Let me go back to the picture.
Mhm.
So let's say if we did not have the front controller, I guess in that case we would have to either use the notation or web.xml to kind of specify each controller.
We would need something similar to what we did.
For servlet, remember how we did it for each servlet?
Yes.
Right? So we would need to do something like that if
Yes.
we didn't have the front
Yes.
controller. So I guess
And we still need to do something like that because the front controller needs to know which individual controllers are handling which things.
So, but then really, what is the use of front controller? I mean, how is it helping us? I guess I don't understand.
It does the auto wiring.
The code
No,
will
no,
be
no,
much
no,
more
no.
cleaner, I think.
Everybody hold on. We can think of this as just being this is the connector between the servlet world and the Spring world. Right? In our servlet world, we had to say which servlets are handling which requests. And we're still, I mean, fundamentally, we're running Jetty. Jetty's a servlet container, so we're still in servlet world. So that's what this dispatcher servlet is. It's a servlet, but it's a servlet that doesn't know how to do anything except delegate requests to other things.
But we still have to tell the dispatch servlet how to delegate the request, right?
Yeah. And so the way that we do that is, so I'll show you as an example here, right? This is one of our controllers. Well, this is the only controller that we have. We say request mapping here. Yeah. So we still need to provide that information. It's just we're doing it in Spring language instead of servlet language.
So I guess the Spring has its own ways of handling things.
Exactly. Yeah.
Not necessarily we are getting any advantage per se.
Not yet.
Not yet.
Not yet.
Okay.
Right. The way I tried to, as I was doing this transformation last night, I tried to make the transformation as minimal as possible, so that you would have some interesting work to do today.
So
right.
is it fair to say that the front controller for that Spring employs actually makes the tasks of writing the controller much more simpler than your typical servlet?
Yes. Yeah. That's a fair way of looking at it. Right. Spring's API for routing and handling requests and all that stuff is a much nicer
auto
API.
wiring and all of that happens. Where does that happen?
So because our controllers are managed by Spring, whenever Spring needs to instantiate one, it's able to auto wire there.
It's outside of the scope of this diagram.
It's not represented in this diagram. So we'll talk. I'm introducing a lot of concepts at once here, so I'm trying to kind of like push back a little bit and just introduce one at a time. All right. So we're still all right. Let's say we're still talking about MVC.
Sorry, I have one more question.
Oh no. Okay. Yeah. Go ahead. No, please. Yes.
So I guess we still same servlet container?
Yes. Yeah. So we're still using Jetty. Like that's the same.
So I guess instead of
And if you were
serverless
using
APIs, we're using Spring APIs. That's the only difference.
Yeah, that's the only difference. Is we're like we still let's sort of say that we still have to use our servlet containers because we spent a lot of money on them or something. I mean, it's like Jetty's free, Tomcat is free, but if you're getting some big commercial application server, probably your management wants you to keep using that, right? And you're probably using it for a reason because it's providing some sort of load balancing and some other high level routing and transaction management and all different kinds of stuff that it's giving you enterprise grade scalability and I don't know what are the buzzwords I can think of. So you're using your application server that you've chosen for a reason, and Spring says, okay, well I've still got to fit into that environment. There are some. So I think a couple of you were mentioning that you've heard of a framework called Play framework.
You were talking about it.
We were.
Scala, right?
Yeah. So it's for Scala or Java. It was originally a Java framework, which is another whole different separate thing. It's basically not servlet based at all, right? There's some. I mean, servlets are a Java technology, but they're not like the only Java technology for serving HTTP, right? So yeah, there's nothing in the world that says you have to use a Java EE environment, right? The only reason why Spring is saying that it's got to fit into that environment is basically for legacy reasons. Okay, anyway, so that's what the dispatcher servlet is all about: is providing sort of a shim between the servlet world and the Spring world, so that we can use these APIs that are better, right? I mean, probably the biggest issue with all of our J2EE stuff is that it was all sort of designed by committee. All this, it was like between like BA, WebLogic, Oracle, and probably Netscape, and all those guys were all in there making the worst APIs by committee that they could possibly think of. Right? The servlet API is a great example. Right? What problems did we observe with the servlet API? Why were we starting to hate our servlet code?
Because for different URLs you would have separate
It was
servlets,
better.
and then with each parameter you would say.
Yeah. So we didn't have like a nice way of saying. I mean, basically, if we wanted to have different behavior based on different parameters, we had to have like a big if-else block. There was no way to deal with that, right? Because each servlet just it maps to a URL and it has one do get and do post and do put, do delete, right? So very inflexible, very rigid. The way that Spring is going to be doing it will be very different. I've kept it so like I said, I've actually kept it basically the same. So I've kept our terrible code because I'm going to make you guys do the work of making it better. Then you'll feel happy about it. But yeah, I mean, the thing that you notice initially is that in our controller, it doesn't implement it, or it doesn't extend from HTTP servlet. These methods, get contact list, get contact, post contact, right? These aren't overrides of something from the HTTP servlet API, right? And each method that I want to be able to handle requests, I've annotated individually with a request mapping annotation. So let's kind of zoom in on that real quick, right? Request mapping. So, this is kind of like our little web servlet annotation before. This thing that said what our routing was going to look like. Value equals / contacts, right? So that's the URL that this method is going to handle, and it's going to respond to GET requests. Right? Okay. / contact is going to respond to GET requests. Different method. And hey, this is kind of cool, right? Different URLs, but they're in the same controller. So, I mean, that's kind of handy. Right? And then we've got another one down here, our /contact that responds to post requests, right? So same, if you look at the code inside the methods here, same structure, but we've organized it at the top level a little bit differently, right?
So we had two servlets, right? Contact list and contact, they both and
Yeah. So what I've done last night is I've taken both of those servlets and smushed them into this one controller, without really changing the code too much, right? Like if you look at this code, it's got the same sort of if request.get parameter add is not null, else if request.get parameter edit is not null, right? So it's got that same structure, and it's also the way that it's populating. The way that it's populating our model is the same, right? We do request.setAttribute, and then we get the request dispatcher and forward, right? So I've kept that stuff all the same. Even though Spring has a much better way of doing it, I've kept it all the same, just to minimize the amount of change, right?
So related to this, like if I choose not to use servlet container for whatever reason, would this be different?
Absolutely, yeah.
This is kind of sort of a glue between these two worlds, right?
Yeah.
But let's say if I choose no servlet container, then
Yeah. So
we might
what we're
have
gonna do
other
probably our first set of exercises today, since I know you guys were starting to get a little tired of Hibernate stuff, is I figured I'd give you a break from Hibernate, and we'll come back to it a little bit later in the afternoon. The first set of exercises today is going to be to refactor and rewrite these get contact, post contact methods in a more Spring style to throw out everything about the servlet API. Right. Right now, this HTTP servlet request, HTTP servlet response, like that still comes from javax.servlet. Right. Request dispatcher, servlet exception. Right. We're still throwing IO exception and servlet exception.
So would we be running sometimes the code outside of servlet container?
No, we'll still be just using servlet container for this. I've actually never used Spring outside of a servlet container, so I don't know how it works. I know you can, but I don't I don't know how it works. Okay. One last. Let's see. All right. So that was discussion about MVC a little bit. Right. So we're not using servlets anymore. We're using controllers. Controllers. We just have methods. These methods can be called whatever we want as long as we annotate them with a request mapping annotation. Then Spring will figure out how to dispatch them. So Spring will call these methods. Right? Yeah, so that's the next thing I want to talk about. So we have a contact repository, right? Our contact controller, just like our contact servlet before and our contact list servlet, like we needed a contact repository, right? We need that. That's a dependency. Before we were creating it by hand, right? Just in here we would say contact repository equals new contact repository. And inside our implementation of contact repository, we would get the entity manager and everything. And so we were dependent on specific implementations of our stuff, right? We were dependent on our contact repository implementation. We were dependent on a particular way of getting an entity manager. We were dependent on exactly how we instantiate these things. But what if, and we're not really going to do any testing in this course, but what if, for the sake of testing, or for the sake of having different deployment environments, for example, like let's say we had an environment that uses our HSQL database in our development and setup. But we use an entirely different database in our production setup, right? Or let's say we have, let's say we're doing unit testing and we want to test the contact controller, but we want to provide a mock for the contact repository, for example. Well, in that case, we're sort of in a little bit of trouble because we've hard-coded the instantiation of these things, right? We don't want to ever hard-code instantiations. We want to do what's called inversion of control. So this is a big, let me stand up for this one, because this is a big part of what this Spring and Hibernate course is about dependency injection and inversion of control, right? The idea in inversion of control is that anytime I depend on some other component, I'm not going to create that component myself. I'm going to ask for it. I'm going to expect that somebody else will give it to me, right? So what's a simple way? Let's say we don't have a dependency injection framework. What's a simple way of saying I want somebody else to provide something for me? Just in standard Java, how would you do that? Factory. Okay, so that's an interesting idea. You would have a factory inside your object, and then
if I was based on string something,
and then get from the factory. Okay. How do you get the factory? Where does the factory come from?
You do maybe like have a setter.
You could name the class and instantiate it with a dot class, right?
Oh, if it has like a no arg constructor, for example.
Outside of factory, you could basically in your configuration you could set up the configuration such that you could provide the name of the class, and your configuration can do a new on the name dot class.
Okay. So we're talking about configuration now, which is interesting, right? Having some central place where you configure everything. Well, still, like where, so you're saying that the factory would then read the configuration file, or something like that.
So you have the application context here, right? You could have a standard XML file or a standard properties file.
Right.
Read it and then instantiate classes by their names.
Yeah, but that's much more like what we're actually doing here, right? That's kind of like dependency injection.
Yeah.
I'm asking about like an even simpler approach, like a just very, very basic Java approach. Like if I have a class that I've got my contact controller, for example, and my contact controller needs a contact repository. I would probably have like a constructor that takes a contact repository, right? Okay, right. Or at least I would have a setter or something like that set contact repository, and then whoever is creating the controller would provide the repository. I mean that's like the simple way of doing it, right? And so at some point, at the very top level of your program, in main or something like that, you would construct all your objects and then have them, do your set whatever repository and set set. Make sure that they all have the dependencies that they need, right? And that's, I mean, to be totally honest, that's not an unreasonable way of doing things. Like that's, in my opinion, that's pretty good dependency injection. You have something that takes an argument, right? Or takes a constructor parameter, or takes, just takes something. So, that's like something very simple that we have in our language. But the problem is that we're working in some sort of a managed environment, right? Based on what we had yesterday, right? We have a bunch of servlet classes that we declared. And the servlet classes were being instantiated by whom? Were we saying new contact servlet? No, right? Yeah, the container was actually creating those. And the same story here, right? Our contact controller is being managed by Spring, right? And so when we're working in these sort of framework environments, we end up running into a situation where there are some objects that we don't construct ourselves. And because we don't construct them ourselves, we don't have any way of passing things into them. So that's essentially what dependency injection is about. Is we need the framework to know not just how to construct objects, but also how to pass things into those objects, right? So let's real quick go back to the application context, for example. So you can see we've got a couple of explicit beans here, right? Let's look at the entity manager factory bean, right? So this says to Spring, hey, you need to be managing a class called this local container entity manager factory bean. You need to be able to instantiate one of those things. Because when somebody asks for one, either asking for it by name or through something called auto wiring, which I'll talk about shortly, when somebody asks for one, you ought to have one. You ought to be able to construct one and specifically be able to inject this Hibernate JPA vendor adapter into it. Again, I mean, this is just fancy terminology for calling setters, right? Calling setters or constructor parameters. But Spring needs to be able to do that. Spring needs to be able to set that stuff up. So our controllers, like I said, our controllers are managed by the Spring environment. And now, additionally, our repositories, and I'm not going to show you the repository yet, but our repositories are also managed by the Spring environment. So Spring now knows how to construct repositories. Spring knows how to construct these controllers. And because I've said that this thing is auto-wired here, Spring knows that when it constructs a controller, a contact controller, it should also construct a contact repository and populate it here. Right? So that's the idea with dependency injection. It's solving the particular problem that we have managed components, and when we have managed components, we don't have any way of wiring them up ourselves. So we need the managed environment to do it for us. That's really all it is. It's basically just a fancy name for letting the managed environment set our stuff up for us. Okay, so that's what AutoWire does. There's a few different ways of wiring components, and sort of in the previous version of this course, like when my boss was teaching it before he got sick of it, he would go through and show you like all the sort of the old techniques, and so he would show you how to set up these beans in the application context.xml, and then how to do like setter injection, how to do constructor injection. But typically people don't really do that much anymore. It's pretty well documented. If you need to see it, you can easily find out how to do it. But the easiest way to do it at this point, using Spring 3, is just with this auto-wired annotation. We've said that we need a contact repository. How many contact repositories do we have floating around our system? How many different implementations of contact repository do we have?
One, but what if you have more than one?
If we have more than one, then we have to get a little bit more specific. So we can choose by name, or we can set priorities. But in a case like this, which is really the majority of our cases, we have one unambiguous contact repository that Spring knows about. So you can just say, use that one. Obviously, right?
If you have multiple, wouldn't it figure out based on the entire class path, I mean the package name dot class name?
No. If they all implement the same interface, it won't really distinguish between them. It'll throw an exception at runtime, saying that it doesn't know which one to choose. So you would either specify that in your context, or actually it's not auto-wired. You would use a different annotation to say which implementation you need. We're not going to see any examples of that here. Okay.
So here you can specify the interface, and then explicitly you would mention what implementation you would like to instantiate.
Yeah, you can do that. So you can do it by name. You can do it by class type. Right. And in fact, if you go back and look at it in application context, our default auto wiring is by name. Right. All right. So here's the thing. I've done something very strange. I've taken so we had our own implementations of contact repository and address repository before, right? And they were pretty simple. I said they were sort of subtly broken in some ways. I've replaced it with this. And I feel very satisfied about this. We now just have an interface called contact repository. It's just an interface. It's not even a class. It doesn't extend anything. It's just an interface called contact repository that extends something from Spring called a JPA repository.
It's like a CRUD.
And this is, yeah, if we go and look at the the interface here, there's like a find all, save, flush, right? And this extends from something called a paging and sorting repository. So find all, CRUD repository, there you go. So that provides sort of a direct answer to your question. Save, find one, exists, delete. Hey, we've got a delete by ID now, so that's kind of good. Right. So I'm introducing a little bit of magic here. I made the assertion that we have an implementation of contact repository. But actually we don't, right? Contact repository is just an implementation. So we've talked so far this morning, already in the last hour, we've talked about Spring MVC. We've talked now about Spring dependency injection. And I'm going to introduce a third thing that we're using from Spring, which is Spring's JPA.
So Spring would generate code for this?
So Spring, yeah. Spring, anytime we want to inject an implementation of contact repository, Spring is going to dynamically generate code that implements this.
At runtime or at compile time?
Runtime. Yeah.
Would that not make it slow?
Again, it's slow the first time, and then it has it, right? And it's not
Like a JIT.
It's sort of JIT, yeah, right? Because it's generating bytecode. It's using that same technique of bytecode generation. So once we have bytecode, it can be JITted.
So this is a Spring specific
This is-
JPA.
This was this. Remember, in the POM, I added two things. One was Spring MVC, and the other was Spring. Where'd we go? Spring Data JPA. So Spring Data JPA provides a few things. Provides transactions as well. We'll be using transactions later on. But this is probably the coolest thing that I know about from this package is its ability to just create repositories on the fly.
So this is above and beyond the spec, the JPA spec.
Yeah, it's an addition. It's basically helpers for JPA spec. Yeah.
In your contact controller, right, you specify AutoWire, right?
Mm-hmm.
So that's for telling that Spring has to create this contact repository, right?
Well, so it's saying two things at once, and this is why I wanted to introduce these concepts one by one. When it says AutoWired, really all that's saying is we need it injected. We need Spring to inject an implementation of contact
How does it know
repository.
where is contact repository? By name, he'll search the class.
By name, yeah. So it knows that it needs an implementation of contact repository. Well, so I mean it's the type. Sorry, the contact repository type. It needs an implementation of of contact repository. That's the dependency injection part, right? It needs to go and find in the Spring context somewhere, in the Spring application context, it needs to find a bean that implements contact repository, right? Well, there is no such bean in reality. So this is where the second thing comes in, which is the Spring Data JPA magic, where it knows that it can actually just magically generate an implementation to inject here.
Do you have to specify that implementation by name in the XML file?
Yeah, the way that we specify it here is an application context. So there's a specific tag in the application context here that says, hey, if anytime I ask for a repository that's in this package, auto-generate it.
How does it, where does it say auto-generate? How would it know?
That's
Because
what
it's a
that's what
JPA.
this means. Yeah.
That's what JPA repository means.
Yep. Yeah, so there's a few magic things in here, right? This says we'll be able to use the transactional annotation. This says we'll be able to generate repositories on the fly, right? But then, talk about transactions for just a second. We'll see that later in the day, probably. We need so our transactions are going to be annotation driven, but we still need a transaction manager. So we still have to say that this will be the specific bean that implements transaction manager. We need a JPA transaction manager because that's what we're doing. Again, you can see why I didn't want you guys to have to figure this stuff all out on yourself. It's sort of ridiculous.
With this approach, I see that a lot of the things we are doing sort of making it configuration based, right? So we define a lot of things in XML or annotation driven and whatnot. How is it in terms of debugging, right? So let's say, I
That's an excellent question. How does this?
Because when
how
I
does
write
this
everything by myself,
Yeah.
I know how to debug. I know, the errors are, error reporting is very clear. And
Yes.
I know where to debug.
Yeah.
How to
Yeah.
fix it.
So the question: how does this affect debuggability?
Yeah.
It sucks.
Yeah. There you go.
I'm just
That's what I was
gonna I'm just gonna
expecting.
say it straight up.
Okay.
This makes it much harder to debug configuration problems. It makes it easy to set up, but if you get it wrong, it's hard to figure out why. Yeah. This is there was a really funny presentation that was given at a Scala conference in Boston over the winter, where somebody was just saying that dependency injection is just a pretentious term for takes an argument, and dependency injection frameworks are basically the biggest evil perpetrated on our whole culture at this point because it makes it totally impenetrable to figure out what's going on. I have to say I agree. I think that if we could get away with what the 15 minutes we were talking about, this idea that really just pass an argument to the constructor of an object, that'd be awesome. The problem with that is that we're working in this managed environment, and basically it becomes sort of a chicken and egg problem, or something like that, because as soon as you have one thing that's managed by the environment and not by you, as long as you have that one thing, then everything else that it depends on also transitively has to be managed by the environment.
It gives you gain a lot of flexibility, but you lose control.
Something like that.
Yeah.
So we do have our ways of exerting control over the system. If we do the right things, where we specify these beans, specify their names, and figure out exactly how to wire them up, then we can regain a lot of that control. But it's really like learning a new language. It really is like learning a new language, and debugging in that environment becomes a very different process. Just using the standard Java debugger doesn't work the same anymore. For example, a problem that we have already, even before we introduced Spring, even when we just had servlets, what order do things get instantiated in? Like when does our servlet, a given servlet class, when is that servlet class instantiated by the servlet container?
When it's needed.
When it's needed, yeah, maybe, right?
Isn't there a configuration?
You can configure that.
Yeah, I think in web or somewhere you can configure.
Yeah. And then there was also like our web listener thing, or like our servlet context listener. And so we needed to make sure that was going to run before all of our servlets. And And so we get into these sort of weird life cycle issues where sometimes, particularly if we have just like statics, like global data, things end up being initialized in the wrong order. So you have static initialization order problems. And that just becomes more and more of an issue when you start dealing with Spring. So, for example, in Spring, let's say I have bean A that depends on bean B, which depends on bean C, which depends on bean A. There are ways of dealing with that. Sometimes you can't. Right?
So Java would compile a cyclic dependency?
Sure. Yeah, absolutely. Right. I mean, because
So how do you resolve cyclic dependency in Java? Like in C++, for example, you wouldn't even link.
Java's perfectly happy to do that.
So at runtimes you run into issue.
It depends on what you're doing in your code. Like if you have A that depends on B and B that depends on A, then you can't have
Right, that's what I thought.
them in their constructors, right? You would have to have setters.
Okay.
But then, let's say you're calling a method on A that depends on B having been set up already, but you don't have a B yet. Whatever. So yeah, basically to answer your question, right? This you can sometimes run into trouble with this. So I don't have a good general answer for how to deal with that loss of control. I'm going to show you the best that I know how to show you kind of like best practices for working with Spring, which would be just keep it totally simple. Have avoid cycles. Just have a simple tree of or a directed acyclic graph, I suppose, of dependencies that you can fairly easily model and reason about. Right. Okay. Time for me to sit down. I need to give you guys some work to do so that I can eat my breakfast because I'm starving.
One more quick question.
Uh-oh.
Your
Yeah.
contact repository interface, right?
Mm-hmm.
Your JPA repository takes 2 parameters, right? The template.
Yes.
Contact and long.
Contact and long.
Why is that the long needed?
The JPA repository interface needs to know exactly what kind of, basically what the type of the primary key for that class is.
So it's not necessary that you'll have a long, right? The primary key. You can have a string as well.
Yeah. For example, if contact had a string as a primary key, then you would say string here. Yeah. So basically, whatever the ID annotated thing for your JPA entity class.
Primary key.
Yeah, whichever one is the primary key, you basically specify that in your repository.
In the contact repository, if you want to implement a different method than the method that are provided by JPA repository,
Mm-hmm.
how do we handle that?
You don't.
We don't support.
Yeah. So we're magically getting this class like just generated, synthesized on the fly for us, right? So there isn't really any way to blend our own implementation details into another one. What you would have to do instead is you would have to create a new interface that depends on one of these. So you would have to get one of these injected as a member.
We can just have another class that implements this, right? And then instead of auto-wiring, do it ourselves. Create the contact repository yourself, right? Equal to new your class.
Right, but the issue is then you have to actually implement all the methods on JPA repository yourself, right? So here's how I would do it, right? If I wanted a special, if I wanted a special, special contact repository, right? So special contact repository extends contact repository, and it's going to have some, void foo. I don't know. Doesn't matter, right? So this is our additional method that we need to be able to provide. Then I would have to have another class, special contact repository impl that implements special contact repository and contains, so it have to be auto-wired, a contact repository impl. I would then delegate, so here let's we'll add all the unimplemented methods here. So I'd have to say, return impl.findAll. Right. This is the only way that we can extend any of these auto-generated things is by containing and delegating, which kind of sucks, right? But the good news is that these like the JPA repository class basically contains everything that you would ever need anyway. I've never seen the need to do it.
You have to manually put in all those functions with the impl.
Yeah, you would. Right, because since the class is generated on the fly, there's no way to subclass from it. I mean that's essentially what we'd like to be able to do. We'd like to be able to subclass from that JPA repository thing, but we can't. It doesn't exist yet.
If at all, let's say you want, well, if at all, if you expect these methods to behave in a different way, I don't know, it's silly, but if at all, then it wouldn't make sense to extend from JPA repository. Let's say if I want to have my own implementation.
If you wanted to have, well, I mean, I can think, for example, let's say that we wanted findAll to do exactly the normal thing, except for also, print line. Something like that. Then, I mean, that's a way of sort of overriding behavior. We can do that. Like we have that flexibility, but you can see that there's some amount of boilerplate that we have to do.
No, but I guess my question was, if I don't want it to really be
Oh, really
it's a
just.
question, but yeah, I wanted to really something totally different. Then it wouldn't make sense to probably extend from JPA repository.
Maybe not. It'll be up to you. Yeah. I mean, maybe you want to be using the raw entity manager yourself. Yeah. So what would you do if you wanted an entity manager?
I don't know. I'm just
Well, no. I'm giving you the hypothetical question here. If I wanted an entity manager injected so that I could use it directly, what would I do? Yeah, auto-wire it. How do I know that it's going to work? Yes. Yeah. So this entity manager is available to us. Oh, actually, no, I'm sorry. It's not. The entity manager factory would be. Yeah. So that's fine. We would be able to oops. Special contact repository impl. So we would get the entity manager factory and use that to create an entity manager.
So he automatically uses that ID to put it. Spring already knows it, or do you do something yourself?
Again, it's based on the type, right? Spring knows that it has a bean that implements entity manager factory, and there is only one such bean that implements it, so we're good to go.
So you wouldn't need to change the XML file?
Presently, we have what we need. Right? We have a bean. We have a bean that, this local container entity manager factory bean thing implements entity manager factory. So
if you don't have this auto-wire and if you want to do it manually with the same bean ID, how do you do that? How do you get this XML bean ID code?
Oh, then you would have to do this horrible thing where you get the Spring application context object and query it for the bean.
There's a static method.
Yeah, there's a static method to do it, but we're not going to. That's terrible. Basically, if you find yourself ever having to do something with the Spring application context, it means that something is terribly wrong in your code.
So if there are more of these, then he finds it by name. Like there's one more entity manager factory, let's say.
So you would have to resolve that yourself. You would
Using
probably.
the context, right? Again. See, like you mentioned, if you're going to test something, right, you have two databases. Let's say MySQL and you have this HSQL.
Mm-hmm.
And based on, you want to do it on the fly, right? Let's say in a testing environment, I want to use.
You would have two different application context XMLs that you swap out depending on which.
Wouldn't it be easier to have just an application context and have two bean IDs and then do it yourself in the code?
No, it's much easier to just swap the XML, right? Because you probably have a lot of different things that you want to configure,
Okay.
right?
Can't you specify another XML here?
I think there may be some way that when you start the Spring context, you can choose. The way that I've seen it done in my production code has been just, when you're building for this environment, you use this file. When you're building for that environment, you use this file.
Is it wrong to mention bean ID, entity manager factory 1 and factory 2 in the same application context?
It's not wrong, but then you have a problem because there's two competing implementations.
Yeah, but the ID is different, so the ID is mapped to again your.
I'm sorry?
This ID entity factory manager factory.
Yes?
That is mapped to the class name, right?
It's mapped to.
In the special implementation which
Yeah. So this says, anytime somebody specifically requests this bean ID, you're going to get this implementation.
Yeah. So I am trying to do like entity manager factory 1 and factory 2 beans here,
Mm-hmm.
and in the code in the impl, if I say entity manager factory 1 and EMF1,
Mm-hmm.
that EMF1 will contain the HSQL related.
Yeah, so if you have it auto-wired by name, then that'd be okay. If this bean ID name matches the name of the variable,
Yeah.
then that would work. Yeah.
Oh.
Otherwise, you have ambiguity. That's what I mean when I say you have to resolve it yourself. All right. Again, I don't want to talk about that stuff. That gets very confusing very quickly. So here's what I want to do. I want to delete this special contact repository stuff. Oops. All right, so let us try to only worry about one thing at a time, because multiple at a time is too hard. I know you guys have a lot of questions because I made a lot of change overnight. Here are the things that are still the same. It's actually basically everything is still the same in terms of structure, right? Our add JSP, edit JSP, like our view code is all still the same. I haven't changed a single line of these. I've just changed the file names so we can stay a bit more organized. Okay. Those are still the same. They're still basically in the same place. Address and contact are still exactly the same as we left them. I haven't touched those either. Yeah. And then if you kind of squint at it a little bit, the servlets that we had, the implementation of those servlets is still basically the same in here in this one controller. Right? We're not implementing HTTP servlet anymore, but still, roughly speaking, the same. So the set of exercises that I want to give to you to start out today is going to be to solve this ugly code problem that we've had, right? Let's take a look at get contact list. Get contact list, just like we had before, takes a servlet request, servlet response, throws IO exception, throws servlet exception, right? This function signature looks exactly the same as do get like we had before, right? How do we populate the model? Well, for the contact list, what's the model? The list of all the contacts, right? Yeah. So contact repository.findAll, that's what's going into the model, right? That's our important data. Request.set attribute, that's, you know, this is the same as we've had for the past 2 days, right? How do we then pass this on to the view? Same as before, right? We get the request dispatcher for our JSP page. Remember, I changed the directory names a little bit, but this is just like we had before. This is like our, you know, JSP/list contacts.jsp, right? And then we say view.forward, right? So we're using Spring as a framework here, but this is still totally servlet style. This is servlet style MVC. We want to use Spring MVC, and that's the exercise for the morning. Is we want to take all of our servlet style stuff and de-servletify it. We're gonna depollute it and just use Spring MVC. Okay. So I'll give you one example of how this works for our gets. We'll do our gets, all of our gets first. Then we'll do our posts a little bit later. All right. Here's what I'm going to do. I'm going to comment this out and show you how you would do this the Spring way. We do the same thing, right? Request mapping. This of course is our Spring annotation. Public string get contact list. All right. First of all, why am I returning string? Any guess? I'm asking you to totally guess wildly here. Any guesses as to what this string might be? If I get a contact list?
Equal to the proper view.
The string is the name of the view. Yeah, that's a good guess. Have you done this before? All right. String is the name of the view. So I would say return contact list.
That's it?
That's the name of the view. We haven't populated the model yet, but that's what this string is. We don't have to say view/contact/list.jsp because in Spring Servlet here, I've said that our view resolver will automatically prepend/view and append/JSP. So these now become sort of logical names, not physical file names. This is, you know, very simple transformation, but it helps. Right. All right. So we return the name of the view, and that's how we tell Spring that we're going to delegate to this particular view. All right. Now, how about populating a model? Any guesses as to what we might do? This is I'll be very surprised if anybody guesses.
Still do the contact repository?
Well, right. So we still, I mean, we definitely need the same data. So we need like contact repository dot find all, right? So we need our list of contacts. How do we put that in a model? Well,
Parameter?
in our get contact list, our previous implementation of get contact list, we took HTTP servlet request and HTTP servlet response, and we set some properties on the request, right? We did request.set attribute. But what we were really using our request object was sort of a container for our model, essentially. We also got the request dispatcher from there and stuff, but what we end up doing is just saying, hey, give us a model that we can populate. Give me a model, and I'll populate it. Model.add attribute.
What is this model here? That's Spring's.
Yeah, so this is a Spring thing. Model is basically just like a map. And you can see, I mean, it's very similar to this request.setAttribute business, right? Request, an HTTP servlet request has a map of attributes. The same deal. Model is basically just a map of attributes.
So Spring injects this model into the HTTP request?
Spring injects an empty model into this method when it's called, right? Spring is calling these methods somehow, right? Right now we've got Spring calling these methods, passing in the request and the response. Well, let's say we don't care about the request or the response. We don't have to ask for them. We can have Spring give us a model instead, and that model will be empty to start with, and then we populate it. So that when we return this view, it can use the model that we've populated.
What about the request data?
I'm sorry?
Like for this method, we don't have any input.
Yes. So we have some different ways of getting this. So I'll show you this one. I'll show you another example as well that uses some request parameters. Right. So this would be the simple Spring way of doing it. You have a method. It's mapped, right? This way Spring knows that it should call it. The method takes a model to populate and returns a string, which is the name of the view. And that's it. We don't need to throw any servlet exceptions or I/O exceptions or anything like that, right? This is all that we need. All right. Okay. What about?
One question.
Yeah.
So the earlier version of the code that we have HTTP server request and response would have worked.
Oh yeah, yeah, it works.
But this is like Spring way of writing the code.
Mm-hmm. Yeah, this is a more Spring way.
So this model, we are setting the attribute, right? So that attribute is the newly added into that, or it exists?
It's the same thing as what we were doing before. When we say request.setAttribute,
Yeah.
model.addAttribute is the
Yeah,
same
even in
thing.
Even in the request.setAttribute, are we request is an object which has already the context field, or we are putting the context field and adding the value?
We're putting it. It's like we're inserting a new entry into a map.
Okay, so there we can even say request.setAttribute some XYZ and then put the value.
Well, that's what we've done, right?
Yeah, there we put the context. So
Yeah.
that attribute name we can put anything.
Yeah. I mean, this, we made this up, right? This wasn't special.
So
Yeah, we just made that up. So we can put anything in the model that we want.
I asked this question because there it is set attribute, here it is add attribute.
Oh, yeah, there's no difference. It's just a different method name, but yeah, same behavior. Okay, let's say
If there is no request and response here as a parameter, HTTP servlet request, so how do we get the more information on the request parameter if we want to get somewhere like in the response? Last time we said that the response we are setting as attribute when we are passing HTML in the servlet in the starting. We were setting up some parameter in the response that it is a type of HTML or text.
Content type.
Oh, content type?
Yes.
Sure, yeah.
How do we here we can set or we can get from the request?
Good, yeah. So, produces,
Okay.
oops, sorry. So this request mapping, and this is something I'm going to want you guys to look at, is so yeah, here this will be the first assignment. What I'll do for you is, let's delete this. I'm going to check this in. Hopefully it works. Actually, let me test that it works. I don't want to be too rushed. One thing I had to disable Jetty's automatic reloading, so that's gone now. It doesn't play well with Spring, so if you're making changes to your controllers, you have to restart Jetty now. All right, so let's oops. Contacts. All right, so that seems to still work. Yeah, so okay, all right. My contact list still works. Let me put this over where it used to be. Okay, let's check this in. So we springified, which one? Get contact list. Okay. All right. So we springified get contact list. So your assignment now. This is gonna be a little bit tricky to start with, but I want you guys to springify get contact. And in particular, I want you to do it such that there's actually two separate methods. One that deals with the add case, or sorry, three separate methods. One that deals with the add, one that deals with the edit, and one that deals with the view.
Those would be called within get contact, or
I want three distinct methods. Three distinct methods that all have different request mapping. So the secret to this assignment, the key to this, is going to be to look at the Java doc for request mapping and understand what the parameters that it takes are. There will be one other thing that you'll need to. You'll need to get parameters from the requests. So we'll talk about that in a little bit, but I want to get you started on this. So the goal is, here, let's right. This is what I'm going to want this to look like, is a method that displays the add page, a method that displays the edit page, and a method that displays the view page, depending on the parameters that were passed. Yep. All right, so that's your assignment for now. I'll give you one additional hint. Just a quick reminder, right? For the add contact page, what was the model? What model does the add contact page need?
add
That's the view. So good though.
oh, model.
No model.
Yeah, add.jsp is the view, and what we're calling it now is contact/add. Right, that's the logical name of this view now, and no model. Right. How about edit contact? Contact/edit is the name of the view, and what's the model?
It's the
Find by ID.
Yeah, find by ID. The method is called find one. Now in our new repository, it's called find one.
Find one.
Yeah. All right. So I'll make a new, let's see, just copy this. All right. Okay. Get add contact. All right. So get add contact. First of all, how do we know that we only want this method to respond to /contact with an add parameter? Params equals add. Yeah. That's how. Okay. Do we need a servlet request or servlet response? No, right. Don't need to throw servlet exception or IO exception. As a matter of fact, let's just delete all of that.
Need the model there?
No.
Do we need a model?
No.
Oh, not for it.
Yeah, not for add. And if we don't need the model, we don't even need to put it as a parameter, right? Since Spring is just sort of doing its magic with this, we can either pass parameters or not pass them if we don't need them. After we're done with this set of exercises, I'll give you a whole list of things that you can pass into these methods that Spring knows how to populate. All right. For now, for get add contact, all we need to do is return contact /add. That's it. Sorry, string. Right. This thing's return the view name. Okay. How about for get edit contact? We need params equals edit, right? Right. That's again how Spring's request dispatcher knows how to, or Spring's dispatcher servlet or whatever that thing is called, knows how to get us to here, right? Is by saying, oh, all right, this URL has contact and a parameter with edit. The view is going to be edit, but we do need a model this time, right? Right. What else do we need?
We need the ID.
Yeah, we need the ID as a parameter. And so we've seen params now, right? You guys found that in the Java doc. So, but we actually need to get the value of the parameter, and that's where request param comes in. Yeah. So we'll have a long ID. We can just get it as a long, right? You don't have to get it as a string and then parse it. Just get it as a long, and that's fine. And we'll say that it's a request param.
The order doesn't matter, does it?
Order doesn't matter. Yeah. So what do you suppose Spring might be thinking about if it sees this?
How does it parse?
Yeah. How does it? Yeah.
Wouldn't you want to do the request param with the name?
With the name, we could. But even better.
Or you could just do it like.
Even better, we can do it like this because this variable name is the same as our parameter name.
That's how he knows?
That's how it knows. It's the variable name. Yeah. Yeah, we could, if we wanted to, or if our variable name we wanted to call something else, we could explicitly say that the request parameter is called ID. But we don't even have to. All right. So how do we populate the model?
On the find one.
Add attribute.
You need to first get it. No.
And what's the value?
Find one.
Find one ID. Right. Okay. That's it for that one. Right. This this is obviously a nicer sort of API to deal with than the servlet API. Right. All right. So that was contact edit, and we need what's the last one? It's contact view, but we don't have like a view param. It was just like /contact, right? So just take that one out. Call this one get view contact. Long ID, model. contact view. I think that's it, right? So we've taken this method that had all three, right? This add, edit, and view, excuse me, all in one spot. That had to parse the request parameters out. We've taken it and split it up into these three very simple methods. So Nipa asked the question before, like, you know, like the fact that Spring is this managed environment makes it much harder to debug, right? Well, that's true when we're talking about dependency injection, right? Dependency injection is a pain to debug. But Spring MVC, the fact that each of these things is an individual method that's very clear about which parameters and which request methods it's responding to, this part of it is actually, I think, easier to debug, easier to work with. Right. So we've got these three separate request mappings. These, you know, so we treat them as just three separate methods, right? Okay. Let's check this in. Wait, I keep doing this. Let's make sure it works. Let's make sure it works. Make sure it works. Hopefully it does.
This
And
seems pretty similar
it doesn't.
Jersey's or Rust
It does. Yeah, it does look similar, right?
is
Let's see, address already in use. Oops, still running. Yeah, this does look sort of similar to JAX-RS, right? Very similar model, right? JAX-RS, the method names can be whatever you want. You annotate them with at path, right? Yeah, so similar programming model. And as a matter of fact, we'll see tomorrow how to implement REST services using Spring MVC. All right. All right. Seems to work. Seems to work. All right. And you notice, by the way, like, as I was running it, it's not too slow, right? The first time we load, it takes a second because it's got to figure out how to create this repository deal. But then after that, you know, we're up and running. Everything is just as fast as it was before when we had coded all out by hand. Okay. All right. So yeah. So let's check that in. Springified.
Did you try the edit function?
Yes.
It worked?
Mm-hmm. All right. So now maybe it's actually a good time for a break. We still have a little bit of work to do. We want to springify the post-contact stuff because that was pretty ugly. But let's take a break. We'll do that after we come back. Mm-hmm.
Now WebXML, why do we have the views separately mapped?
Because so remember I said we were sort of cherry picking from different technologies. This is actually pretty typical. The views are handled by not by Spring. The views are handled by the JSP compiler, which again is Java EE standard stuff. Nothing to do with Spring. So we're using I should mention this, by the way. We're using JSP to implement our views. There's nothing that says we have to. JSP is one particular templating technology, right? But we could be using Velocity templates, which is an Apache project. We could be using straight HTML, right? Yeah, there's nothing in the world that says we have to use JSP. It's just because we were sort of using it already. I didn't want to change too much stuff.
So JSP integrates with JavaScript.
JavaScript.
I mean, you could have mix JavaScript and like jQuery invocations within JSP.
Oh, sure. I mean, JSP, like, all the JSP is just a templating language. So we can put whatever HTML we want in there. Doesn't even have to be HTML.
But within the JSP tags, can you invoke jQuery calls? You wouldn't be, right?
No. Within JSP tags, it's Java. It's all Java, right? Right. Anything outside the JSP tags is anything we want it to be. Anything inside JSP is Java stuff. Right? And again, you know, I like to keep it fairly simple. So I'm not really using any JSP like scriptlets or anything like that. I'm just using EL, just using those like $ curly stuff.
Oh, I see.
Yeah. But yeah, if I wanted to include some jQuery in the page, I could. I mean, because it's just, you know, it's arbitrary. JSP doesn't care.
So if you don't want to, okay, it's correct. It's the correct way to do it is to have the views separately behind. But if you want, can we do it in Spring? Call the dispatch level.
Yeah. So there's a few ways to do it. We'll see probably tomorrow. We'll see a way where, you know, instead of returning a string that references the view name, we can actually return view content directly. We'll be doing, basically we'll be treating our REST responses as views. So our JSON content we'll be treating as views, right? Yeah. So yeah, so the fact that we're using JSP here isn't special, but because we are using JSP, we still have to configure it for configure the JSP servlet.
Even if we use JSP, is there any way to return the content here and then figure out, picking up the view from somewhere? Or it has to be here?
That's a good question. I mean, there's probably.
The question is because here we're sort of hard coding what view we wanted to.
Right, we're hard coding the view name. Yeah.
So I guess if we purely return the content.
Yeah. So for example, let's say you wanted to switch on the accepts header.
Yeah.
Like that'd be very normal, right?
Yeah.
Right. If the accepts header was to accept HTML, then we would return this view. If the accepts header was application JSON, then we should return JSON directly.
Right.
Yeah. So we'll see how to do that. All right, let's take a break. It's already almost noon, so say 10-minute break or so, and then we'll finish up with post contact. The reason, by the way, I wanted to do this stuff, this cleanup, before we get back into any more Hibernate stuff, because we're not done with Hibernate, right? The reason I wanted to do this cleanup before we get back into more Hibernate stuff is so that we don't compound our problems too much, right? Our servlet was looking pretty ugly, and we were going to introduce several more, because we're gonna introduce new stuff in our data model that's going to have additional servlets and so on. So I wanted to make sure that our code was relatively clean so we could add to it without really pulling our hair out too much. All right. So that's going to be the plan. Basically, we're going to, after the break, we're going to clean up post contact, and then we'll spend a bit of time before lunch talking about more JPA Hibernate stuff. Okay.